Everyone's had a great day at Cloud Native Storage Day so far, all learning about all the great stuff that has to do with Cloud Native Storage. So you're probably wondering, what does security have to do with storage? Lots, as it turns out, because if your storage is not secure, then by default it is insecure, I guess. It's kind of a binary operation. Anyways, we've got a panel of experts here, and then we'll leave 10 minutes for questions at the end, because I'm sure some of you have some questions. And we're just going to do an overview and talk about some of the basics about how cloud native security applies to cloud native storage. So I'll just introduce our panelists. We'll start with Glen. If you just say a couple words about yourself and your company, what you do.
Hi there. My name is Glen Kosaka. I'm with NeuVector. We're a startup company in San Jose, California. We started about 3 years ago in the Kubernetes security platform space. The founders of NeuVector come from companies like Fortinet and Trend Micro and VMware. So we really wanted to combine the runtime, production, and networking aspects of security with the cloud native parts that you are familiar with virtualization. Kubernetes is now the new VMware, I guess you could say. So thanks for joining us today, and look forward to interacting with you about this.
Hi, I'm Sonya Koptyev. I'm the Director of Evangelism from Twistlock. Twistlock is also a startup that's roughly 4 years old, and we focus on cloud-native cybersecurity. So focusing on securing your entire stack, and not just limited to cloud-native technologies. We also secure things that happen to be on-premises or VMs that you build on your own, all the way through to containers as a service, functions as a service, and then also straight serverless as well. Yeah.
Great. Well, thanks, Glen and Sonya. And then if you are curious who I am, live long and prosper. I'm Sean Michael Kerner. You can follow me on the Twitters at Tech Journalist. I also write for eWeek and a few other places. And I write about cloud native stuff. I also use the stuff, but I am a basic script kiddie. So I will just download Docker, Kubernetes, or whatever, and then run it, and then spray and pray, hope that it works. And we'll start with you, Glen. What am I doing wrong? So if I'm just running, a cloud native deployment, Kubernetes, pick your vendor of choice, or upstream without any kind of external security tool native, what am I doing wrong for my data security? And am I seriously, a little bit crazy?
Well, I mean, not knowing what exactly you do, you're probably doing a lot wrong. But I think the good news is that...
Thank you. Very kind of you.
You've
been talking to my wife, obviously.
I do the same thing. I play with Kubernetes. But the good news is you and I are not developing business critical applications for, massive scale production deployments. So, simple things that we're probably doing wrong are not really locking down and evaluating all the access controls, whether it's to the, proper service accounts, to the namespaces, to the storage, the secrets, the volumes, all of that really needs to be carefully done. And then, of course, in a production environment, there's a whole bunch of things that need to be done to secure not just the storage for cloud-native applications, but the entire infrastructure, from the Kubernetes orchestration system to the apps, the pods that are running themselves. A lot of it is just traditional stuff that you probably are familiar with non-cloud native apps, right? Just making sure you have the right visibility, that you're doing vulnerability scanning before you put things into production, that you're locking down your access controls, that you have proper secrets management. All of those things need to be taken care of before you actually go into production.
Great. What do you see, Sonya?
Sure. So I'll add on to, there's probably a lot that you're doing wrong. But
beat up Sean Day,
right?
That's okay.
But last week the big Kubernetes CVE came out, right? And I think that speaks volumes to the fact that we take for granted, just because it's Kubernetes that's hosted and managed and running on one of the big cloud providers, that it's inherently secure, right? Don't ever take that for granted. And so one of the biggest things is actually being on top of those CVEs or vulnerabilities and also compliance checks that you would need depending on what it is that you're doing in your environment. But in general, just being up to speed and having a tool that does plug into the latest and greatest and alerts you and monitors in a real-time capacity in runtime, but then also something that can help you as you're developing your software, right? Something that you can set certain security thresholds or vulnerability thresholds as your developers are building so that they don't get out of the development phase before they meet those certain requirements and compliance checks and measures, right? So again, things like having clear text passwords, I don't know, in your database or keys, right? Things like that are just the digital equivalent of having your username and password post-it noted on your monitor, right? And that came out on Twitter last week as well. That's funny in LA.
A challenge.
So yeah, I think there's a lot that can be done to make sure that
Great.
Kubernetes and Docker aren't inherently secure and that you can lock it down so that they are.
Yeah, and then just from a larger perspective, when I think of storage by default is generally stateful, because if it's not stateful, it's not actually stored. I'm full of this. I'm here all week, people. It's not stateless. And when I think of Kubernetes and general container stuff, it is stateless and non-persistent. So when we think about it from a security concept, how do you, both of you, and I'll start with you, Sonya, reconcile that concept of the statefulness of storage and the stateless nature by definition of a Kubernetes or a cloud native deployment?
Yeah, I think it all really comes down to, are you encrypting and are you watching for certain things that can get either plugged into your calls as they happen into your database, right? Are you encrypting when you're pulling that data out? And so that then helps to reconcile between that stateless, just asynchronous calls that you have going between your microservices and the stateful information that then gets stored into the database. Another great way is knowing exactly how your microservices should be communicating between them amongst themselves, if you will, and then also to your data stores. So if you know your normal state of behavior, and then you can identify anomalies that happen on different ports, for example, or things that are trying to pull out data when you know that data is only supposed to be going into your store. Things like that are definitely ways to track threats that happen in real time, but then also mitigate them to shut that threat down as it's happening.
All right, what do you see, Glen?
Yeah, I like to think, if I'm thinking about data security, I go back to the high level and think about, okay, what are some of the basic questions? Okay, I have to be able to identify what is my sensitive data, right? What do I consider to be sensitive data? And then I need to figure out where is that sensitive data going to be stored, and then how is it going to be transmitted or communicated? So if I can answer those questions, whether I'm in a cloud environment or not, then I'm at least I have an idea of where things can go wrong, where I'm vulnerable, and where data stealing can occur. So so there's all the traditional things like being able to protect your database, being able to protect all of the access to file systems and those things, but when you transition from, let's say a microservices or from a monolithic environment where you had one big app and, maybe that sensitive state was stored in memory to a microservices environment where you've got all these pods running and now they're communicating over a network interface or an API interface, you got to think about, okay, am I more exposed now? Is that sensitive data that's going between pods at risk, and how am I going to get visibility into those network connections? So that's a difference that you got to think about in a cloud native environment. The other things have to do with the infrastructure itself. Kubernetes and its system services. The vulnerability that Sonya referred to, is a real serious one because it can enable someone to really get into your system and essentially take over any of the pods and the nodes that they're running on. So, access controls. How are you protecting access? How are you authenticating users, and where are you storing that authentication? So that's something that needs to be considered. You may be familiar with secrets and secrets management. Those are key logins or keys that are used for apps to be able to communicate with each other. Where are those secrets being stored, and how are they being secured? Because that's another point. in which your data can be stolen. So ultimately, wherever your sensitive data is, you don't want to end up on the headlines. So, when people get in, I tend to think of it as, okay, there's a couple things that I need to be concerned about at a high level. Data theft or data stealing. How am I going to detect if there's connections or external connections where they're using tunneling protocols to steal data? The other thing that I might be concerned about is like data destruction, right? They might not be trying to steal data, they might be trying to corrupt all my data and damage my business. I think of ransomware as a form of data destruction. So ultimately, security is a multi-layered approach. There's no one tool that's going to give you all of the protection for all of the layers, but you need to think through all of those different layers and then apply the proper tools to that.
Yeah, that's a good point. I like the idea of security by default, but that doesn't quite work. And security is not the default in Kubernetes, so defense in depth is the order of the day. And then I know Glen mentioned some of the things, some of the differences, or some of the similarities between traditional storage security and how we're doing it with containers. I'll start with you, Sonya. What do you see as the fundamental differences, I guess, between traditional data storage security and cloud-native container security story? Is it storage security? Is it just more of the same and applying the same types of policies that everyone in this audience has been applying for decades, or is it a fundamentally different approach?
Thanks for that lead-in, but I think it's a fundamentally different approach. We've obviously increased exponentially the layers of complexity that are added in a cloud-native software solution, right? You've got so many different components, and all of them are generally talking to each other over networks and protocols and things like that you didn't have in traditional software development. And so you've exponentially increased the exposure landscape that you have to your application. And so each one of those different components is going to require a little bit of a different approach than just the siloed way that we used to do it before. And I think understanding and knowing what each layer of the stack requires and what security can be applied to your data layer, to your OS layer, to your host, to your containers, right? And to your different APIs that are running in those images and in those containers. And then also how your microservices actually interact with each other. Obviously, restraining to least privilege is a basic cornerstone of security. But yeah, it absolutely requires a very different approach. And then having insights into how you would normally secure all of these different components and best practices, but then also being up to date with the latest CVEs that do come out and compliance checks that need to be handled across your entire environment is key and core, I think, to making sure that we release secure software.
And we've got a third panelist because we always need lots of people in security. Rani, if you could just pass the mic to Rani. Rani, if you don't mind just introducing yourself and where you're from.
I'm Rani Osnat from Aqua Security, VP of Product Marketing there. I think also relevant for this is my past experience, because before Aqua, I worked for the last 7 years before that for a cloud storage company, and before that for a database security company. So I have a bit of a wider angle.
Nice. So since you just walked in and are out of breath, the question I was asking is, given the background that you have, what the difference is between cloud-native data storage security and what it is now, and what it had been just with traditional data storage security.
Right. So obviously, we're talking about a much more dynamic environment. Although if you have persistent storage, that storage in itself is managed maybe in a very similar manner to traditional storage, access to it and how it's being deployed and used in production environments is very different. And so I think that's where a lot of the difference lies. You have to manage this dynamic environment, you have to manage access, and you have to have some sort of visibility into what's being used where and how it's being accessed.
Great. And then what do you think, Glen?
Yeah, I would agree that it's a totally different dynamic environment. I think each application development team needs to figure out architecturally, do they need persistent storage? What do they need it for? Is it just temporary state? The access, how do they control access to it? What are potential attacks that people are going to try to use to try to gain access to it, and really how critical is that if it's temporary state of an app, and then when the pod goes down, then it's no longer relevant. So is it that critical, or is it so critical that you need to have all of the traditional protections for it?
Great. And we've talked about all kinds of interesting ideas, some of the differences between cloud native and traditional security. Since all of you work for security vendors, you've seen customers, and these customers, without naming names, sometimes do intelligent things. Sometimes they're like me and not so intelligent things. What are some of the best practices? What's the most overlooked, rather, aspect of container data security that you've seen that the customers that you've talked to and the deployments that you've been involved with have overlooked? And then when you're in there, you say, hey, you really missed this. And we'll start with you, Glen, and work down the row.
Wow. So, we do constantly talk to companies that have put Kubernetes into production, or Docker, EE, Swarm into production without any security. And
don't do that.
Maybe, some of them think they're doing well enough by doing vulnerability scanning before they get into production. Or, perhaps it's better to be able to run the CIS benchmarks and at least make sure that you're not getting any red flags, on the access controls and how your daemon is set up and things like that. But we still continue to see people going into production without the proper controls, without proper network visibility. You would never put an application into production without being able to detect both network attacks against it as well as application layer attacks, right? So if you have a business critical application, why would you launch a bunch of pods where you have no visibility of how the pods are communicating to each other over the network or what's actually happening in every pod? I think a lot of it is the enthusiasm of the dev and the DevOps teams to get these things into production. It's so exciting, and there are so many benefits for being able to rapidly deploy applications and beat your competitors up. I think part of that is also that there hasn't been an understanding of what are the security issues with a cloud native deployment. And it's not until things like the critical CVE, the Kubernetes vulnerability that happened last week, that people are going to start to say, before we go into production, I better really take a hard look at how it's all configured. Is everything locked down? How am I going to monitor this into production? And I also predict that we'll continue to see, attacks and exploits in the next couple years. Part of it is because there are unknown vulnerabilities that haven't been discovered yet. And part of it is just misconfigurations. So I think the thing that you guys could do is make sure that there's no misconfigurations, that you don't have default password set, that you have the proper access controls, and then stay on top of those vulnerabilities as they come out.
Great. What are you saying, Sonya?
Oh, that's okay. Thanks. I think one of the common things we see is, again, taking for granted the fact that if there is an image, in an open and public repository or registry, that folks download it and think they can just use it, and that just opens the door wide open for crypto miners, right? And I think that's some of the biggest things we see in folks that just think, oh, well, this is from the Docker registry and it's public and I can use it, and let me just throw it up there and see what happens. No, you absolutely must scan and lock things down, and also go through and make sure that the image that you pull down is going to actually be doing what you want it to do. And folks have gotten pretty stealthy with renaming or hiding packages and shifting them around, so folks don't really realize that it's a crypto miner. So be careful there, along with what Glen said.
Great.
Yeah, I think specifically with regards to the data layer, there's a couple of things. First of all, a lot of the access to things like volume mounts is not secured by default. Mm-hmm. You have to do this, right? You have to limit access to this. The second is, and I noticed this in the abstract for this panel, you shouldn't just think about how do I secure my data against being exposed, let's say in a Kubernetes cluster, but also, thank you, but also, maybe not. but also about how how it works in the other direction. I mean, let's face it. Today, at the state of things today, a typical database deployment is more secure than a typical Kubernetes deployment. That's just the way of things are right now. So you could think of exposing data to through a Kubernetes deployment or any other container deployment as kind of a backdoor into your data. In other words, if you don't do things properly, you're actually at risk of letting people into your databases through your cloud native deployment. So it's actually worse than than just risking a cluster or a container misbehaving as a crypto mining container. And so you have to remember that these things work both ways, right? So it's having a proper policy to secure your cluster, of course, but not just to protect the cluster, but also to protect access to the data, and vice versa.
Couldn't agree more. We've got about 5 minutes left, and I wanted to make sure we leave time for questions. So if anyone has a question, Lisa, will you run the mic to them? Thank you. If anyone has a question, happy to take it, and we can pose it to anyone in the audience. Don't be shy. If not, I got more. Any questions? No questions. Oh, we got one. Great. Thank you, sir.
They decide now to get
Thank
shy.
you, sir. If
They're
I had
afraid of you,
stickers or a
Sean.
shirt, I'd give it to you, but I got nothing.
I was just wondering if you could talk to like data destruction when you clean up persistent volumes and that sort of stuff. What's available in that space?
I was blinded not by the question, but by the projector. So first of all, on your cloud native deployment itself, there are ways to clean up data. One of the things that we recommend, for example, is not to use anything persistent unless you have to. So the persistence, I don't mean don't use persistent storage. This kind of negates this whole discussion. I mean use persistent storage, but don't make it persistent on a host, for example. So if you use volume mounts, they're supposed to be to disappear after. If you're storing things in memory, better. And that way you make sure that you don't leave any dirt. And of course, there are practices within the cloud native space that allow you to do that for other things, and you can apply that to data as well, just in terms of refreshing. So there are companies out there that, for example, refresh all of their containers every couple of hours or every 4 hours. That's a practice that some companies can take. It has some operational overhead, but that really ensures that if you were compromised in some way, that attacker, loses everything they did.
Great. Any other comments on that one? The only other thing I always say with destructive malware and that kind of thing is backup, backup, backup. On Windows, there's always shadow copy, and there's things that you can do to check whenever there's some kind of runtime thing that's trying to do something evil, and that will help you out. So back up and be worried. Never have a unique data snowflake because it doesn't last. Any other questions?
Any other questions from the audience? And you can ask Sean questions too. I deliberately chose him for this panel because he's quite the expert in security as well. So
Some
not
days.
just a journalist.
Some days. Go ahead.
Why isn't security something that's set as a default? Like, for example, Kubernetes secrets, right? Why isn't that encrypted?
It's the same. That's a great question, first of all, and I'll jump in on that. It's the same reason why until Kubernetes 1.4 it didn't have role-based access control, so anyone could access anything, which is just craziness. Literally, because until a year and a half ago, there was no way to do Kubernetes by default secure. What smarter people than me will say, and panelists can chime in, is that Kubernetes was designed by developers for developers. At a KubeCon 2 years ago, Joe Beda said that, what did he say? He said that Kubernetes is not exactly great because it's for developers, so it's ease of access to get started and not for deployment. So it's an afterthought. It's just the genesis of how things work. Doing security by default makes it harder to set up and deploy, right? Because you're restricting as opposed to unrestricted. When everything is unrestricted, that's it. For me, as a script kiddie, whenever I want something to work, I just chmod 777 and magically it works. By the way, that will invalidate just about any kind of Kubernetes security. You chmod your storage volume. If you allow that, 777, read, write, allow everything, then you're screwed. Any comments from our panelists on that one?
No, I agree. It's security. You know, I wouldn't say it's an anathema to the mindset of the cloud native community, because it's not. But certainly traditional security is. So I think there's a process that we're all a part of, and our customers are all part of changing the way security works so that it fits into this model of CI/CD, DevOps, DevSecOps, deploying applications very quickly, and so forth. Because the traditional security model is hold on a second while I pen test and DAST, IAST, and whatever other scanning type of technology we have for the next 4 weeks, and then I'll approve your deployment. Well, you can't do that when you deploy 4 times a day.
Yeah.
Thanks. Just to add to that, yeah, I mean, historically, security was thought about as an it was an afterthought. It was the developers developed the software and then handed it off after QA and, all of the standard things that it should be doing, it was doing. Then security got to it and, they said, okay, well, let's lock this down, let's lock that down. And they may have had to go back and developers may have had to have tweaked. Now with developers and IT ops and DevOps and security all getting into a room together, now that's when security gets pushed left, right? That's what we talk about when we say shifting security left, is it actually the onus gets put on the developer to secure the app as they're building it rather than as an afterthought.
Yeah, the only other thing, sorry, go ahead, Glen.
Yeah, I agree with everything that was said. There is a shift left movement, and that's great because developers are becoming aware of security, but they'll never be network security or runtime security experts, right? So I think the good news is that there's at least in cloud native, there's this term now that's shift left and then shift right. Because you've got to build security into the beginning of your pipeline, but you also have to build it in all the way through your pipeline, all the way into production. And there was a lot of excitement with the DevOps and the dev teams to getting these things out and demonstrating how fast a company could move. Now that these things are actually running real apps, then you're starting to see the more traditional security architects be part of that team. Whereas I would say a year ago, they were not part of that team. We'd meet with people and it was the engineering manager and maybe a DevOps person, but never someone from the InfoSec or security architecture. Today, they're part of that initial discussion, so they can evaluate these types of settings and configurations, as well as figure out when they get to runtime what they need to already have in place.
Yeah, it's a standard discussion across all of IT for me. Selfishly, if everything was secure by default and baked in, I'd have nothing to write about and be unemployed, and that would be bad because then I'd have to ask Lisa for a job. We're at the end of our time, and I know there's another speaker coming. I think it's you, Bassam, isn't it? You're up next. Yeah, there he is. So coming up next.
We have a few. Aaron as well.
That's great. Well, and thanks to our panelists for joining us, and for all of you talking about cloud native security.
Yeah, and can you stick around? I mean, we have a happy hour at 5, and I'm sure there's many more questions to you. People are tired and at the end of the day and probably a little shy, but if you guys mingle around, I guarantee you people will have questions for you. Okay, so everybody give them a big hand. Thank you so much. Thank you.